Okay, so in this lesson, we're going to look at transformations. We're going to, in particular, talk about vertical shifting, reflection about the x-axis, horizontal shifts. We're going to talk about stretching and shrinking in later lessons. It won't be in these lessons here. But when talking about transformations, you're basically going to take the parent function, a parent function, which is your basic function, and your basic functions are going to be your quadratic, which is x squared, um, and then the other one would be absolute value of x. That would be a parent function, your basic function. And then the other one we're going to talk about will be the square root of x. So it'll be those three basic functions, those three parent functions that we're going to take, and we're going to transform them into other functions. Okay, so you can see what that's going to look like. So in each one of those, though, before you transform them, you need to be able to graph each of these basic functions, each of these parent functions. Remember, these are called parent functions. So we're going to call those the parent functions. So that's the most basic function, and from those you graph other functions of that type. Okay, so first thing we're going to do in this lesson is going to talk about the quadratic one. So let's go ahead and graph f of x equal x squared. And to do that, you're gonna label 5 points. You're gonna plot 5 points, okay? And it is those 5 points that you're going to move along to get the other transformations. So these are the 5 points you're going to use, and you're going to see how that's going to work when we start looking at these transformations. So always use these 5 points for x squared. When x is 0, 0 squared is 0. When x is 1, 1 squared is 1. When x is, remember we're getting this, y equals 1 squared, which is 1. When x is negative 1, I get y equals negative 1 squared in parentheses, which is a positive 1. When x is 2, I get y equals 2 squared, which is 4. When x is negative 2, I get y equals negative 2 squared, which is also 4. Okay? All right, and then what that looks like in terms of your graph is this. So this would be the parent function that you would draw each time. And you're going to see what I mean by drawing each time. So let's go ahead and use blue. So you're going to plot those 5 points, okay? So you get 0, 0, and I'm using a transparency here. So you get 0, 0, you get 1, 1, you get 2, 4, you get negative 1, 1, and negative 2, 4. And all you're going to do is just connect those. Remember, that's a parabola. So do the best you can with graphing this parabola. All right, and so that's your parent function. Now notice that this parent function has symmetry. It is an even function. It is symmetric about the y-axis, so it is an even function. Okay. All right, so that is f of x equals absolute value. X squared. Excuse me. F of x equal x squared. Okay, now let's graph this, or let's talk about this now. All right, suppose, okay, so I know what this parent function looks like. We just graphed it. But what would this look like? F of x equal the parent function, but I'm adding 5 to it. So let's say if you wanted to graph that. Okay? Well, let's think about what's happening to the y coordinates. And then we're not going to do all of them. We're just going to do a few points. And I want you to start thinking about this. So I'm still going to use the same x coordinates here. So when x is 0, but let's think about this. Remember, if this 5 wasn't there, that would be the parent function. So 0 squared is 0. We put a 0 here. Forget about the 5 for right now. Just cover this up. If x is 1, I'm going to get 1 squared, which is 1. So I'm just rewriting these over, basically. When x is negative 1, I get negative 1 squared, which is also 1. When x is 2, I get 2 squared, which is 4. When x is negative 2, I get negative 2 squared, which is 4. Okay, but I am adding 5 each time, so this is plus 5, plus 5, plus 5, plus 5, plus 5. So what you think about is this. For these x values, these y values from the parent function, I am increasing the y values by 5 each time. So 0 plus 5 is 5. 1 plus 5 is 6. 1 plus 5, oops, yeah, 1 plus 5 is 6. 4 plus 5 is 9. 4 plus 5 is 9. Okay? And I want you to see what's going to happen now. I want you to notice something. Okay, so remember this was the parent function. So let's go ahead and graph x squared plus 5. See what happens. So I'm going to go ahead and cut this. Okay, so I get this. Now let's put this over this. I'm going to use a different color. All right, let's say. All right, so remember what I'm graphing now. What I'm graphing now is g of x, which equals x squared plus 5. Okay, g of x is x squared plus 5. All right. So remember, if you go back here, So I plot the point 0, 5. So here's 0, 5. I plot the point 0, 6. Here's 0. I'm sorry, 1, 6. So here's 1, 6. I plot the point negative 1, 6. That's here. I plot the point 2, 9. That is right here. Move it down. 2, 9 is right here. And then negative 2, 9 is right here. So when what I want you to notice is this now. I'm not going to shade in just yet. I want you to notice this. Okay. So I take this, put it over here. Make sure. Okay. All right. So remember this was the parent function. Remember. All right. So remember what's happening. What's happening each time is, remember, I added 5 each time. So when I add 5, notice what happens when I go from the blue graph to the green graph. So I'm trying to get to the green graph. To do that, notice I've got to move this blue graph up. And notice when I move it up, then everything is aligned. See? Everything's aligned. So let's talk about this again. So here's my parent function. So I'm going to take my parent function, I'm going to shift it up. See how I'm shifting it up? I'm shifting it up. Okay. So I'm taking my parent function, I'm shifting it up 1, 2, 3, 4, 5. And then it's aligned. So I shifted how many units? Shifted it up how many units? I shifted up 5 units. Do you see the number 5 in here? Where's the number 5 located? It's located on the outside. So when it's on the outside of your parent function, that's a vertical shift. Plus 5, if it's positive, you're going to go up that many units. If it were negative, you'd go down that many units. Okay? All right, so that was that. So now I'm going to go ahead and shade this part in. All right, so I'm going to graph it like this. All right, do the best you can. I'm running out of ink on this, but do the best you can. So basically what happened again was this. So you're going to graph your basic function, your parent function. The plus 5 indicate I'm going to go up 5 units. So every point's moved up 5 units. And so I get this. Okay, so again, notice what happens. Okay, watch. Okay, so let me kind of align these back now. So let's see here, and then here. Okay, so watch what happens. So all these 5 points are every point of this graph. I'm particularly use those 5 points. I'm going to take each point, I'm going to shift it up 5 units. Okay, so watch what happened. 1, 2, 3, 4, 5. I get that point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so what you do, so you just take each of those 5 points and you shift it up 5 units. You draw your new graph. Okay? All right, so that was that one. Let's see. Okay, so let's graph this now. All right, let's use the idea we just saw. And let's do this. Use the graph of f of x, which equals x squared, to obtain the graph of g of x, which equals x squared minus 7. Okay? All right, so use the graph of x squared to obtain the graph of g of x, which equals x squared minus 7. All right, so So here's what you're going to do on the worksheet or on the test. You will first of all graph the parent function. All right, so let's graph the parent function. Remember, it's the same 5 points each time for x squared. So you're going to say 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. And then you connect them just like this. And there's your parent function. So this is f of x equal x squared. Okay? Now, what I want to do, though, is I want to graph g of x, which equals x squared minus 7. All right, so see how that negative 7 is on the outside of your parent function? So that means that that's a vertical shift. So this is a vertical shift. All right, so you can go 7 units down. That's what that means. Vertical shift, 7 units down. So you take all these points here and you move it down 7 units. So all you do is just count. You count the number of grid marks, grid lines, number of units. Start with here if you need to. 1, 2, 3, 4, 5, 6, 7. 1. Start this now. Do that other point. So you have 5 points that you know of. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, and then all you do is connect them like this, and you're done. Okay, but I need for you to tell me, well, you already did, so that right here is g of x. All right, now I want you to notice something. Take that transparency again, and I want to show you something. So, see this right here. So there's my parent function. I am shifting down 7 units. So watch. 1, 2, 3, 4, 5, 6, 7. And when I go down 7 units, it overlaps with my g of x. Okay? So that's your vertical shift. So that's what you would show on the worksheet. Okay, now let's look at this. Okay, let's talk about a horizontal shift. Okay, horizontal shift. All right, horizontal shift. So again, we're talking about f of x equals x squared. Okay, and we know that the points that we're going to use when we graph the parent, and we got to graph the parent function, so we know that the points we're going to use would be 0, 0, 1, 1, negative 1, 1, 2, 2, 4, and negative 2, 4. Okay. Now what I want to do there now is look at this. Suppose I had g of x, which equals x minus 1 squared. And let's use the t-table. And let's go ahead and still use the same x coordinates. So let's just say x is 0, x is 1, x is negative 1, x is 2, x is negative 2. Let's just use those same x coordinates. And let's determine what the y coordinate is. Okay, so remember g of x is the same thing as y, so I get y equals. In parentheses, if x is 0, I get 0 minus 1 squared, which is a negative 1 squared, which is 1. So I get 0, 1. Okay? When x is 1, I get y equals 1 minus 1 squared, which is 0 squared, which is 0. When x is negative 1, I get y equals negative 1 minus 1 squared, which is a negative 2 squared, which is 4. When x is 2, I get y equals 2 minus 1 squared, which is 1 squared, which is 1. When x is negative 2, I get y equals negative 2 minus 1 squared, which is a negative 3 squared, which is 9. Okay? Alright, so now I'm going to plot those points. I'll plot the points. And then we're going to see what's going to happen. Let's see. All right, so I'm going to do that. I don't want to, just going to make sure I don't throw away these things. Okay, so let's plot those points. I'm going to use the transparencies on this one. All right, so remember this is x squared right here. Remember that? That's your parent function. All right, so let me cut this and just going to show you what's going to happen to talk about that horizontal shift. All right, so now I'm going to plot those points in green for those that we just talked about. So this right here. So I'm going to plot these points here. Okay, 0, 1 is here. 1, 0 is here. Negative 1, 4 is here. 2, 1 is here. Negative 2, 9 is here. Okay? All right, now I want you to notice something. Listen carefully to what I'm about to say. Okay. Put this over this now. All right, so this is what we just plotted. All right, and this was my parent function. All right, now notice, if I move the parent function to the right, just like this, it overlaps the green dots, right? See it? So again, I'm going to talk about this again. So I moved to the right, and the question I'm going to ask you is, how many times did I move to the right? How many units did I move to the right? I moved 1 unit to the right, okay? I moved 1 unit to the right. So that means that when I shade this in, just like this, okay, do the best you can. I kind of messed this up now. Okay, just like that. When I moved 1 unit to the right, so remember it was here. When I took this, I moved 1 unit to the right. I didn't draw it very well, but it should overlap this part. I get the graph that is this function right here. Okay, this right here. All right. So remember, I moved 1 unit which way? I moved 1 unit to the right. So students get confused here because they see that x minus 1, so they think negative 1. They think, well, I got to move it 1 unit to the left. Well, it's counterintuitive of what you would think. So the horizontal shift is counterintuitive. So always remember, do the opposite of what you think for the horizontal shift. So you're going to move it 1 unit to the right. Okay? So x minus 1, 1 unit to the right. If this was x plus 1, counterintuitive, you move it 1 unit to the left. All right, so we're going to talk about that. All right, so it's 1 unit to the right. Okay, now let's talk about this. Okay, so I'm trying to find that sheet I was working on. Here we go. All right, so use, this is going to be number 3, I think. Use the graph of f of x equal x squared to obtain the graph of g of x, which equals x plus 2 squared. Okay? All right, so remember, if it's on the outside, it's a vertical shift. If it's on the outside, it's a vertical shift. So this was 7 units shifted down. This was 5 units shifted up. So I take the parent function, shift it up 5 units. Take the parent function, shift it down 7 units. Here, see how the plus 2 is not on the outside of x squared, but on the inside? That's a horizontal shift. So remember, that's a horizontal shift. And then it's 2 units to the left. So it's counterintuitive. So don't say that's a plus 2, so I go to the right. You go to the left. Okay? So in terms of the graph, this is what you would show. In terms of the graph, you would graph your parent function first. So the parent function is the points are 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So that's your parent function, just like that. So that is f of x equal x squared. And then to graph the this function, g of x, you're going to take each of those points and you shift it to the left 2 units. So here's what you do. You just go 1, 2, 1, 2, 1, 2, 1, 2, and then 1, 2. And then you just connect it just like this. Okay, just like this. Okay, and notice the blue. If you shift it 2 units to the left, I get the green. So let me show you again. So if I take, this is x squared. So if I take x squared, just like this, move it 2 units to the left, 1, 2, I get the green. Okay? Alright, so that was that one. Alright, now what about this one? Oh, make sure, I forgot to mention this, make sure you tell me on the worksheet that remember, this is going to be what the final one you're interested in. So you can say this is going to be g of x, which equals x plus 2 squared. Okay, make sure you say that. Alright, then let's look at this one. Let's talk about reflection now. Reflection about the x-axis. Okay, so reflection about the x-axis. Okay, so again, we're going to look at the parent function, f of x equals x squared. All right, but this time I want to graph g of x, which equals negative x squared. Okay? Okay, so let's see what happens when I apply points dealing with negative x squared. So I want you to see this. If x is 0, I get y equals the opposite of 0 squared, which is still 0. When x is 1, I get y equals the opposite of 1 squared. 1 squared is 1, so this becomes negative 1. When x is negative 1, I get y equals the opposite of negative 1 squared. Negative 1 squared is positive 1, but this is still a negative 1. Okay. When x is 2, I get y equals the opposite of 2 squared. 2 squared is 4, so this becomes negative 4. And when x is negative 2, I get y equals the opposite of negative 2 squared. Negative 2 squared is 4, so this stays negative 4. Okay? All right, I want you to notice something. If you go back to the function we did earlier, remember, we'll put these on the side of each other just to show you. So remember, this was f of x equal x squared, and this is negative x squared. Notice the x coordinates the same, but what did you notice about the y coordinates? About these y coordinates compared to these? Well, the y coordinates are opposite of each other. So the x coordinates stay the same. You see that? It's the y coordinates that changed. They became opposites. So when you graph this, I want you to notice something when we graph this. Alright, so I want you to notice something. Let me go ahead and put this right here. Alright, so here is my parent function. Okay, here's my parent function. So what I'm saying is that 0, 1 here, 0, 1 became 0, negative 1. Negative 1, 1 became negative 1, negative 1. So basically what's happening is that I'm getting these points here. I'm getting these points here. Let me do this. So I'm getting these points. I'm getting this point. Positive 4 becomes a negative 4. I'm talking about the y values now. Y value 1 becomes y value negative 1. The x coordinates stay the same. 0 stays 0. 1 becomes negative 1. And 4 becomes negative 4. The x coordinates stay the same. And when I connect them, I want you to notice something. You see this right here? So the blue graph, watch this, the blue graph is a reflection about the x-axis. So that's how I get the green graph. So if you take the blue graph and the parent function and reflect it about the x-axis, I get the green function. Okay, so blue reflected about the x-axis becomes a green one. So the reflection about the x-axis is that negative in front of your parent function. So it's going to look like this. So f g of x will equal negative x squared. So that right here is a reflection about the x-axis. Okay, reflection about the x-axis. All right, so basically, the way you're going to do this, on the worksheet is you're going to grab the parent function first. Okay, so you can grab the parent function first. So you're going to get 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Then connect them just like this, and then you're just going to reflect. Remember, this right here is f of x equal x squared, and we're interested in graphing g of x, which equals negative x squared. And so basically, this right here is a reflection. So you can reflect x squared about the x-axis. Okay, and so basically, when you take this point, reflect it about the x-axis, you get that point. So y value of 1 becomes y value negative 1. Y value of 4 becomes y value of negative 4. 0, 0 stays 0, 0. Y value of 1 becomes negative 1. Y value of 4 becomes negative 4. And just connect them like that. And so that's what you would show. So we'd show the parent function and the transformation. And again, if you just take your parent function, just like this, and reflect it about the x-axis, you get this. That's all it is. Okay? So that reflected about the x-axis. All right? Okay, so that's going to take care of that part. Okay, now, so let's talk about, I'm going to take this off. Okay. All right, now let's talk about this. So use the graph, this will be number 4, I guess. Use the graph of f of x, which equals x squared, to obtain the graph of g of x, which equals x plus 3 squared plus 4. Okay? So use the graph of f of x to obtain the graph of g of x, which equals x squared plus x plus 3 squared plus 4. Okay, now a couple of things you need to be aware of when using transformations. When using transformations, I can find this page. Let's see. Okay, well, I can't find it, but you're going to do the horizontal shift first. Always do the horizontal shift first. Okay, horizontal shift first. So that's going to be the order. You can do the horizontal shift first, if there's one. Then you're going to do the reflection about the x-axis next. And the last thing you're going to do will be the vertical shift. Always do the vertical shift last. Okay? So horizontal shift first, reflection next, and then vertical shift always last. If you do it in a different order, your graph will not be correct. It's got to be in that order. Okay, horizontal shift. Now, if we were talking about stretching and shrinking, then you would do that after the horizontal shift. So you do the horizontal shift, stretching, shrinking, then the reflection, and then the vertical shift. Okay? But these would be the only 3 that we're going to do in these lessons. So again, if you do it in a reverse order, your graph will be wrong. You got to do it in that order. Okay. So here's what you can do on your graph paper. On your graph paper, you're going to do this. You're gonna graph x squared first, your parent function. So graph x squared first. All right. So graph x squared first. So remember your 5 points. Always do your 5 points. 0, 0, 1, 1, 2, 4. Negative 1, 1. Negative 2, 2, 4. You connect the dots. So you draw your parabola. Okay. All right. Now remember the next step. Okay. So first we graph the okay. First you graph x squared. Okay. Second, you're going to do the horizontal shift. Okay, so remember this part's your horizontal shift. This is your vertical shift. So remember it's counterintuitive. So you don't say 3 units to the right. You got to say 3 units to the left. So you're gonna take x squared and then shift horizontally to the left 3 units. Okay, so you're gonna do this. So you're gonna take all these points and you're going to shift to the left 3 units. So that point, 1, 2, 3. This point, 1, 2, 3. This point, 1, 2, 3. This point, 1, 2, 3. And this point, 1, 2, 3. Okay? And so you get this, just like that. All right, so notice you think about it, if you take this transparency again, and you take that x squared, and you shift it 3 units to the left, 1, 2, 3, you get this. Okay? All right, now don't forget, make sure, I didn't do it with this one, but make sure you label your graph. So this is a graph, f of x equal x squared, so that's my parent function. So far, what I have so far is, I'm doing that horizontal shift, so far I have this, x plus 3 squared. And now you're going to do your vertical shift. So now you're going to, the third step would be to then shift vertically up, shift vertically up 4 units. And it's up because this is a positive 4. Alright, so then I'm going to shift this thing up 4 units. So every point of the green graph is going to shift it up 4 units. Okay, so here we go. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. And then just draw your graph. And this is it. So that's the graph you wanted. So this is g of x, which equals x plus 3 squared plus 4. Okay, so that's that one. All right, now, the next one, suppose you want to do this, number 5. Use the graph of f of x, which equals x squared, so that's your parent function, to obtain the graph of g of x, which equals this. Okay, which equals that. All right, so notice the order. So first of all, is there a horizontal shift? The answer is yes. Okay, so you're going to say first you're going to graph the parent function x squared. So then second thing you do, then you're going to shift to do horizontal now. So you're going to shift, and then it's counterintuitive. So it's 2 units to the right. So shift 2 units to the right. Okay, and it's shift horizontally. So let's use the word horizontally. Okay, then the third thing you're going to do is then you're going to do the reflection. This reflection. So then reflect about the x-axis. And the last thing is the vertical shift, but there is no vertical shift. Okay, so that's the steps you're going to go through. It's very simple. Just do those steps. All right, so what you're going to do is this. You're going to show this on your graph. So you can do the parent function first. All right. So 0, 0, 1, 1, 2, 4. Get this. Then negative 1, 1, negative 2, 4. Okay, so you get this. All right. Then you're going to shift to the, remember, shift to the right 2 units. So you can shift horizontally to the right 2 units. Let's do that with green. So you can go 2 units. 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. And so there's the green. Okay. So far we have this. We have that this right here is x squared. The green is x minus 2 squared. And now we got to do the reflection. All right, and so the reflection, remember you go to the green now. Okay, so remember what's happening is this. So what's happening. So I'm taking the parent function, I'm moving 2 units to the right, and then you're going to reflect. So that's what the final graph should look like. Okay? It should look like this. All right, so basically what you're doing is you're taking each of those points and you're going to reflect it about the x-axis. So the y value, which is 4, becomes a negative 4. The y value here, which is a 1, becomes a negative 1. This y value, which is 0, stays 0. This y value, which is 1, becomes a negative 1. And this y value, which is 4, becomes a negative 4. And so this is what you get. There's your graph. Alright, so let's make sure we understand this. So the first thing we have to do is we have to graph the parent function. So let's use some transparency. Parent function. Then we'll shift it 2 units to the right. And then we're going to reflect. Okay? Alright, so that was that one. Alright, let's do this one. Okay, so where's that sheet of paper? Okay. Alright. Okay, number 6. Okay, use the graph of f of x, which equals x squared, to obtain the graph of g of x, which equals this. I think I already did that. I'm sorry. I already did that. Excuse me. Okay, so that's that. I already did that. Okay, let's do one more with this. Let's say we want to do g of x, which equals, let's do 3 of them together. Let's say negative x plus 2 squared minus 4. Let's do that. Okay, so remember the order. The order, you got to do the horizontal shift first, then the reflection, and then the vertical shift. Okay? All right, so we're going to take, first thing you're going to do is you're going to graph x squared. Second thing you're going to do is then you're going to do the horizontal shift. So then you're going to shift it to the left 2 units. Then shift to the left 2 units. Shift horizontally 2 units to the left. Okay. Then you're going to do the reflection. So then the third thing you're going to do is you're going to reflect. So then reflect about the x-axis. And then you do the vertical shift. So this is negative, you go 4 units down. So then the fourth thing you're going to do is then shift vertically down 4 units. Okay? Alright, so let's go ahead and graph this. So So you're going to graph the parent function first. So 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Just like this. Okay? And then you're going to, the next thing you're going to do, is you're going to shift horizontally to the left 2 units. So remember what you're doing, what's happening is that you're taking this right here, and you go to the left 2 units. Okay? All right, let's do this as green. So to the left 2 units. 1, 2, 1, 2, and then 1, 2, 1, 2, and then 1, 2. Okay? Looks like this. All right? So then you're going to reflect now. So the next thing you're going to do is reflect. So you're going to reflect that green graph about the x-axis. So this y value of 4 becomes a negative 4. This y value of 1 becomes a negative 1. 0, 0 stays 0, 0. This y value of 1 becomes a negative 1. This y value of 4 becomes a negative 4. And so you get this right graph now. Okay, and then finally, the next thing you're going to do is you're going to shift vertically down 4 units. So take all the points in this right graph and shift down 4 units. Okay, so notice what happens. Well, let me do this. So what's going to happen is this. Okay, so this right here, so you're going to go down 4 units. So watch the vertex. 1, 2, 3, 4. See how it looks? That's what it's going to look like. Okay? Alright, so watch. 1, 2, 3, 4. Alright, let me do a blue pen. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay? And just connect them like this. Just like this. Alright, and just kind of do this again. So remember we had this, and then we said we're going to shift it down 4 units, so watch. 1, 2, 3, 4. See, it overlaps. Alright, and so this right here, this is going to be your final graph. That's the one you want. So this is g of x, which equals negative x plus 2 squared minus 4. That's it. But that's all you're going to show. You're going to show the parent function, then you're going to do that first transformation, then you're going to do the second transformation, and then you're going to do the last transformation. The last transformation is your graph. So that's how you're going to graph these. Okay, so that's going to take care of, one other thing. So let's kind of review what we did so far. So let me quickly get some information that we're going to need to kind of review this. Okay, so we talked about a vertical shift. Okay, and so if you're taking a function, you're adding a number to it. Remember, you're adding a number on the outside, then you're going to shift it up that number of units. If you're subtracting, you're going to shift it down that number of units. That's vertical shift. For horizontal, if the number is in the inside of the function, you're going to go it's a horizontal shift, and it's counterintuitive. So it's x plus c. You're going to go c units to the left. If it's x minus c, you're going to go c units to the right. Okay? So c units to the left, and then c units to the right. So there are a couple examples here. Then next thing I wanted to show you was this. The other thing we did. Then we talked about the reflection about the x-axis. So there's a negative out in front of the function, like a negative x squared. Then we reflection about the x-axis. Okay. We didn't talk about vertical shift or shrinking. I'm sorry, stretching or shrinking. We're going to look at this in the next lesson, just to kind of remind you about that. And I think that is it for right now. Let's see. Yeah. Okay. So let's go ahead and end this, and then we'll talk about the next part.